All right, welcome everyone. Good day, welcome, and thank you for joining us today for another presentation. This time we are talking about autonomous AI agents. So I'm sure that you probably heard about this AI agents, and you may be wondering what is all that about? What's the whole idea behind that? Isn't that just chatbots or what have you? What makes them? What is it that makes them so different than any other type of AI bot that we have out there? So with today's presentation, we are hoping to cover some of that more in detail and let you know what this AI agent concept is all about. So welcome to today's presentation. My name is Oscar Garcia. Thank you for being here. So allow me to introduce myself. I work around technologies like web, data, and AI technologies. I love to join with you and speak about different issues and things. I enjoy sharing some of the knowledge with you. I'm also an author of the book Data Engineering Process Fundamentals, which you can actually find on Amazon. Um, you have uh, you have my code right there. You can scan that. That takes you to some of the resources that we are going to be covering today. So let's get going. So there is a GitHub repo behind the stuff that we are presenting today. So you are free to go ahead and find that. And basically, let's get going. All right. So what is this whole agent concept, right? But it's just basically a software bot, right? That sort of observes and figures out what to do based on those observations, right? And it does it automatically. It knows how to do it, but then how does it do it, right? How does it know what to do, and what makes them capable of observing what is happening? So let's talk about an example. For example, let's take as an example a manufacturing setting. So basically here, if you can picture, it's just sort of an assembly line where companies are building something. It could be goggles, devices, phones, what have you, right? But usually what happens here is that you have monitor sensors, right? um, in real time. So, and the whole purpose of this is to actually track the quality of what's being manufactured, right? So we tend to read data points and measure them against control limits. And basically, what that means is you sort of track the quality of the product. If it is going out of those limits, then there is some failure happening. But an agent can actually have the capabilities to monitor this in real time. How does it do it? We are going to cover that uh, in detail. But then the agent, based on what it's observing, it can decide what to do next. Whether it can trigger an alert, it can pause the production, it can just flag the maintenance team to be able to say, look, something is trending in a bad way. We need to go ahead and do something about that. But the agent also can act, right? It doesn't have to be waiting for someone to click a button. It can actually just send an alert, shut down a manufacturing line. It can send notifications. It can do something, right? So it's actually capable of making those decisions. But you may think, right? What makes it so different, right? It's so different from a traditional automation because we could sort of automate this. So if you want to picture what an agent looks like, just take a look at that image that is here. And basically what we have here is an orchestration. We have an agent that actually receives an input, and it can use some tools to be able to have memory, to be able to have AI, right? And able to act on something like sending an email, reading Google Sheets, and so on. So this is a very high level picture of what an agent looks like. And as a matter of fact, this is one of the sort of orchestration tools out there that require no code for us to be able to build agents. But what makes them so different from just a normal automation, right? What's the difference here? It's really the autonomy, right? The autonomy is what makes them different from just an automation. When you build an automation, it just really you follow a script, right? When you build an automation script, you follow a workflow where you say, if this condition, do that. If this condition, do that. But when you don't define what that condition is, it doesn't know what to do with it. So an agent is able to act upon those conditions that you don't predefine, or just basically learn from those conditions and make some decisions. That's what makes it autonomous, right? It has awareness, it has judgment, and it has initiative to do something. So the key components here for an agent really are the perception, right? It's able to observe real-time data from sensors, from machines, from APIs, just like an operator does, right? But it's able to look at this data and observe and kind of reason about what's going on. So the reasoning component enables it to analyze the trends, the patterns from different data streams that are coming in, right? And it's actually kind of understanding, which is the beautiful thing about AI, that it's able to understand based on what you're doing, what is good, what is trending positive, what is trending negative, what's going out of control, and so on. So it makes it a perfect fit for this kind of agents. And it takes action, right? It takes initiative by doing the alerting, by doing the shutdown of the lines, and so on. But what powers this autonomy, right? What is the magic behind this? What is the core technologies of this autonomy, right? This is really the secret power of it, right? That the agents just don't automate, but they observe, think, and act using the following core technologies. For perceptions, it's able to ingest real-time sensor data. So it handles an input, right? It can handle some sort of input, and it actually is able to reason around that input based on short-term memories or windows of time. So basically it's able to say, based on what I have seen in the last 30 minutes or an hour, based on your time span, it can reason about not just the data that's happening now, this second, but I'll also correlate that data to whatever is being, it can remember. If it is 30 minutes ago or an hour ago, and it will take that snapshot of information in memory and reason with it, right? So it's gonna know, hey, based on what I have seen, I know something is happening. So what makes it reason, right? What is it that is capable for it to say, I see this data, I see this window of information, but what is happening here? So for reasoning, usually an agent uses a AI model, whether it's Gemini, OpenAI, Llama, what have you. But this engine, this model is what it enables it to understand, right? Understand the context of information, the data, and is able to, based on the conditions that you provide, be able to detect violations, out of control conditions, and understand the process behavior, right? But it's also able to take action. And it takes action by using what we call MCP tools. And these tools could be anything, could be APIs, database, interfaces, email, chat, what have you, right? But how does the agent really know what these MCP tools are? And as a matter of fact, what are these MCP tools, right? So there is something called Model Context Protocol, right? And this is really a new communication framework that enables us to basically, with metadata, define a tool, right? And this tool is APIs, databases, email engines, what have you. But the whole purpose is that you may have an API. Let's take as an example this post API, RESTful API that sends a notification, right? That's your classical API definition with a content type, with a recipient and message and priority. But this, the agent cannot understand, right? It's what we developers can really understand, and we create code to be able to call that API, but agents don't work that way. Agents, what they need is some metadata that it's able to understand. And it's not really the agent for se, it's really the MCP protocol that enables this kind of bridge, this communication protocol. So the metadata for that tool can just look like the content that you see on your right, where it reads tool metadata. We define the tool name, we describe it, we set up examples on how to call it, and we actually have an execution definition with the type, like a webhook, APIs, database, methods, endpoint, payload mapping, and so on. So if you notice, you were just kind of building out the description of that tool, right? And if you can think about AI, and if you work with AI, especially large language models, you will understand that the more context you provide to the AI model, then the more it knows, right? So this is basically you need to start thinking into prompts. How to define this in a way that looks like a prompt, so the model can consume it and understand what you're talking about. So in this example, for example, the agent just basically will say notify supervisor alert, and the MCP engine will actually be able to map it to the tool that is registered within your solution, within your agent. But how does the agent really understand MCP, right? Do we have to write any code to be able to say, hey, call this or call that? And that's where really this tool metadata definition comes in, right? So the way that the agent understands MCP is that it doesn't really have to write code to call that API. It's not like we're asking the agent, hey, can you generate code for us and call this API? It doesn't do that. What it does, it really just declares an intent, right? So it basically will say to the MCP, hey, I have an intent to notify using this supervisor alert tool, right? And this is my message that I'm sending. The whole idea here is that if some conditions are going out of control, we need to send a notification. That's really the intent of this notification here. So what the MCP tool does, it actually matches that intent to a registered tool, as we saw on the previous slide, right? It looks at the metadata, it understands that you're talking about this tool, it understands that that tool exposes a method for you to call this supervisor alert, and it actually even has an example of how to execute it. So it's going to use the AI model to sort of understand this and basically go through what's called the execution engine to be able to say, okay, so this is a type webhook. Therefore, I know I need to go ahead and call this HTTP request using the following metadata: endpoint, methods, headers, and so on. So the end result of that is that the API call is made, the alert is sent, right? So, so what you got to remember out of this is that the agent describes what needs to happen, but MCP handles the execution. So the action is handled by MCP, which is a fundamental component of building these AI agents. All right, but how do we orchestrate this, right? So we have MCP, we have the agent, we have some data as input. How do we know that we're talking about we need to do this is a manufacturing data stream, and we need to track control limits or whatever the scenario is for your business or your project? Then we need to sort of provide that feedback to the agent. So this is done through prompting. So prompting is fundamental here as well. So we need to provide the agent what's called a character, right? Identify the role, point of view, and a way to think. And the way to do that is that we need to write a prompt to be able to tell the agent, hey, this is what your goal is, and this is what you're supposed to do, and what the data should look like. So for example, we can provide what's called a system prompt. And the system prompt really defines that role and tone for the strategy of this agent. So basically, it could be something like, hey, you are a manufacturing agent that monitors vibrations and applies SPC rules to detect risk. And SPC is basically the control rules, right? So not to go out of limits within the measures of the data. So this basically sets up the stage, right? Sets up the character or the role for that agent to be able to say, okay, I'm in a manufacturing scenario. I know I'm going to get some data, and I know my job is to analyze it for control limits violations, right? So that AI models are very good at, because they understand that with words. They understand that we're looking at control limits. We're looking at a data stream for manufacturing. So it has already learned about that, right? With all that data training, it understands what that means. Excuse me. So once you have that system prompt, you need to define now what's called the user or agent prompt. And this is really what delivers the instructions, right? This is what really says, hey, look, I got this data stream, or let's say manually you can say, look, I got this data. Can you analyze it, right? That's the agent prompt. In the case of an automation or an orchestration, the the agent prompt could just be a data stream, a payload of data, right? So once the agent sees this payload of data, it assumes that system prompt, and it says, oh, I gotta identify this data, and I know I gotta do control limits on it. So let me go ahead and process that information. So it will analyze the sample of data, it will detect trending conditions, and basically can signal a shutdown or an alert, right? So this just basically gives you a foundation how to build an agent. But how do we get started, right? What is the process for us to do that? So to get started, of course, you need to have a little bit of knowledge with AI agents and models, right? And also what tools and frameworks to use, right? So in this case, I mean, there are many options out there, but I can only speak for a few of them. So in this case, I'm going to talk about LangChain, which is a core framework for integrating tools, vector databases, APIs, and so on. And you can use Python, you can use JavaScript for that. LangGraph, which is an orchestration and state management library, right? So basically, the LangGraph would enable you to build this orchestration of you're gonna get an input data stream. You're gonna analyze that data, and you're gonna output some concept, right? It could be or an action. It could be a data analysis. Could be send a shutdown signal. Do what have you. So that is what LangGraph would enable you to do. That orchestration. You have also Langsmith, which enables you to monitor and do the evaluation of the agent. So basically, think about now ops, right? Operation, DevOps, ML ops. When you start building your agent, how do you monitor the quality of your agent? How do you update the agent, and so on? So that framework also enables you to do that. And that's all of it on the coding side, right? So what if you don't want to code? What if you want to go for one of these platforms that have zero code? So you can use something like N8N. It's a no-code orchestration platform that enables you to draw and build agents using all these technologies, and enables you also to deploy them within their cloud stack and basically monitor them and so on. So it really depends on your direction and your capabilities, and also your budget. Because if you do select a framework like that, a platform like that, then you have to pay for everything, right? You have to pay for every request, and you got to pay for the license of your models. If you're paying for something like Gemini, then you got to pay that, or you got to bring your own models and not have to pay for the model. So you just got to think about the billing conditions, or the bill structures of how you're going to pay for the technology that you are using. So let's recap here, and then let's take a look at a project. So let's take a look at a project now. So I'm gonna show you this. I'm gonna go ahead and just quickly go to this GitHub project. I'll put it on the chat really quick. You can follow that, please, if you do me a favor. You can start and follow that project. That helps us grow it, build it, and continue to add more information to it. But essentially, this GitHub project is an AI project that has a few use cases, right? It has how to generate code with AI, how to do chart analysis, how to build AI agents. So we're talking about AI agents here. And you can go up to that folder and take a look at all that, right? And you will see some of the what we're trying to build here, how you can install it. You can clone the repo, install the dependencies, and run it. Of course, you need a license for your Gemini or your OpenAI or whatever it is that you want to use, and you just need to plug in that model. But then you have some Jupyter notebooks here that will enable you to run that code, right? So it's easy to kind of prototype and run it and take a look at that. So let's take a look at that code and see how that works. So this is the same Jupyter notebook that we just looked at it from the standpoint of the website. And so what you want to do is once you go to AI agents, manufacturing, open this land graph data analysis file. You see it there. Let me blow it up a little bit. Right. So what you do now is this notebook will take you through all the installations, right? How to install your Python environment, install the dependencies, and so on. So you got to be careful with that, with the understanding of what dependencies to install and so on. So keep that in mind. So basically, once we install the dependencies, we can import those libraries. And in this case, we're using LangGraph, right, as we talked about. And we're going to use a few components here. We're going to use StateGraph, which is what enables us to build an orchestration. With StateGraph, we can build that concept of an input node, an execution node, an output node, an action node, and so on. So we can build all those things, right? And we're going to use a Google Gemini for this, right? You could use any others, OpenAI, and so many of them out there. So you're not bound just to do that, right? And then we import a few libraries like human message and system message. And the whole idea of this is what we use for our prompting, right? So these are just information of dependencies. Make sure you have like Python 9.5, 3.95, I'm sorry. So make sure you have that kind of information. Otherwise, some of these libraries won't run, right? They won't run on anything lower than 3.9 for Python. But anyway, so let's get this. This is the beginning, right? So you're going to, for Gemini model or whatever you're using, you need to have a license key, an API key, so to speak. So we're going to set up our key and we're going to build we're going to instantiate, establish our AI model, which is Google Gemini. And we're going to say we're going to use Gemini 2.0 Flash, right? That could be anything other than that. That's a particular model for this simple integration. And we set up our key. So now we have our large language model set up and ready to go. So now, if you remember, we talked about we need to set up our system prompt. We need to give the agent a character, a role, right? So we define our system prompt based on what we're trying to do here. So here we're saying, hey, you are a specialized control chart monitor agent, right? And your job is to basically assess if the process is trending out of control based on sensory readings and SPC rules. And this is basically the rules assess you are within control or not. Okay, and don't worry about the semantics of this particular industry. Just understand that those are the rules for that industry, and rules are different across the industries. And just sort of understand the approach, right? How we're trying to do this, and then we're saying to the system in the system prompt, use this: observe, acknowledge a new reading. This is important because this is what enables it to kind of understand that, okay, I'm in the lookout for new data entries, for new data feeds, right? Reason, explain the status of the trend status or any kind of rule violation, control rule violations. And then recommend an action. Monitor, alert supervisor, shut down the system, right? And this is really the three building blocks of any agent, right? Observe, reason, and act or action. And this is really what we have just defined. And this is a very simple system prompt. It could get a lot more complicated based on what you're doing, but the goal is to kind of define what the agent is really looking to do for you, right? And then this is just an example of what a sensor data could send to us, right? So to understand sort of, this is kind of a robot out there in the manufacturing lines that's actually sending vibration data, right? And it's actually it's telling us the value, the current reading, the trend window. So it's saying, hey, I have captured the last 5 or 4 readings, and it's actually giving us it actually provides to us what's called the control limits, the upper and the lower control limit. So that means data points outside that range are out of control, which signals that we have a bad process, right? So and that's the definition for this use case, right? It could be different. But so now we sort of have a background on what we're trying to achieve when it comes to building out the agent, right? So we want the agent to monitor our data. But how does LangGraph and help us build this, right? So the way this works is once you get familiar with LangGraph, is that we need to define sort of a orchestration, right? A workflow. And what we usually do is we sort of define what's called the ingest node. And then each node basically is what enables us to build a workflow, right? Step 1, step 2, step 3, and so on. So we're gonna define an ingest flow, and we're gonna pass the state information there. And the state is usually the state of the agent, right? That's sort of the memory of the agent, right? So it knows that it has interacted for such a period of time and is getting continuous data feed. And that's important for the agent to sort of understand. All right. And then the node to analyze. So we can analyze the data by looking at it and understanding its role, which is to monitor for out of control conditions. And it will just use the structure of observe, reason, and act. That's what we're giving the analyze node. And then the output, right? The output could be an analysis, or it could be an action. It could be sending an email, an alert, or anything like that, right? In this case, we're just displaying a response to the terminal. So basically, this is the visual, right? To help us understand what this orchestration looks like, this is the visual graph. So basically, it will just start by ingesting a message. It will analyze it using the large language model that we selected, and then it will display an output for that agent. Very simple. But this is really what it looks like even for no-code type integrations or development. And we'll see a no-code solution next. But so we start writing the code, right? So we want to do some helper functions to be able to help us understand what's going on. So we're going to display the agent response. And this is just really, we're going to get a response from the AI, and we're going to be able to break it down and display it. Okay, so that's just for the output. So now let's go ahead and start typing our state workflow or orchestration. We're going to start by providing what's called the agent state schema. And that basically gives us the structure, right? It's sort of a class. It is a class, and basically provides what does the data look like, right? So in this case, we have input data, which is a JSON, right? It's a dictionary in Python, sensor data, which is another JSON, and the response will just be a string. So we create this state schema, and we define our state graph, right? So we instantiate our state graph, and we say, look, okay, so now we know what our data, our input looks like. So let's go ahead and define our nodes. And our nodes basically is our ingest, right? The ingest node basically will take the input string and do something with it, right? And chain the state with it, right? So basically, that's where the concept of LangChain comes in, because you're building a chain of nodes and you're linking them and you sort of digesting all that information. Then we're going to create the definition for analyze. And analyze, that's where we actually get the data. We build out a prompt with the system message, the human message, which is the reading basically that we're getting. And this is what's going to enable us to say, using this AI model, analyze this data using all of this information. And that all that information, meaning I'm an agent that I'm looking for data points for control charts, and I'm analyzing out of control conditions and so on and so on. And I'm looking at this data payload. So, and it will just take that and analyze it. And that's where large language models are really good at. Right? So it will just go ahead and invoke the large language model. It will use that internally, and it will just generate a response and send it back to us. And then the output is our last node here, that basically what it does, it actually says, okay, so I'm getting this response and I'm displaying the analysis. This is just a simple output to say display the analysis, which we saw at top, where it says, hey, I observed this and I reasoned with this and so on. Okay. Let me see, I'll catch up with any. Okay, right. So going back to this. So, okay, so now we have the nodes, and we're gonna build a graph. All right, so we have our graph, and we're gonna add the ingest node, the analyze, and the output, right? And now we have the nodes, and we're gonna create edges, right? The edges are the links between nodes, and we're gonna link the ingest to the analyze, and the analyze to the output, and the output to the end of our workflow, right? Which is basically, we just built this, right? We just basically built that. So now that we have our orchestration graph, now we can go ahead and compile a graph and then send the input. And the input is basically sensor data, right? The sensor data that we saw at top, right? That we saw here. And this is just a simple manual input that we're doing, but imagine real time, right? This could be a data stream, like a WebSocket or a Kafka data stream coming in a split seconds type, and it's just sending all that information to our agent, and our agent is consuming it and processing it in real time, right? So at this point, then we create our graph, we compile that, we send that sample of data, and then the agent is going to ingest that data, and it's showing it's right here on the output. Is then it sends that data to the analyze node, and the analyze node uses the large language model to be able to send back a response. And it's actually saying, hey, new vibrations read and receive. And it's just giving us the reading, which is 89, which is right here from the value. If you can see me highlight my mouse here, at top is the 0.89, and it's saying that current reading is within control limits, which are 0.5 and 0.9, which is basically what we provided in the data feed up here. And it's saying, however, the two previous readings in the trend window, 0.94 and 0.86, exceeded current readings, right? So that means it's detecting that even though this data point is kind of good, I'm seeing some anomalies here. And usually that's a bad sign for going out of control, right? So it says, what is the action? Monitor the next reading closely for continued downward trend. So what that means is right now it's kind of watching and thinking, okay, I saw that data point. If another comes in, it's going to do the same analysis, but now it's going to remember. It's going to use that memory in that window of time and say, oh, okay, so I remember the last readings were trending this way. The new readings show me that they're trending the same way, or maybe they're correcting. And it will say, okay, so the new readings is showing me that they're correcting. continue to monitor, or it may say, oh, the readings are going completely out of control. Something is wrong with the process. Let's signal a shutdown or stop of the process, right? And so basically that's what it does, right? It actually says new vibration reading, does the output, and it just does the whole, and this is the raw data basically that is outputting. But of course, this gives us a nice format of the function we created. But for you to basically understand what that data looks like in a real world, is that you're looking at this. This is really what you're looking at. You're looking at lower limits boundaries, which is 0.5 for the vibration, right? And upper limits basically 0.9. And our readings basically, so control limits are 0.9, between 0.9 and 0.5, and our readings are this blue line here, which we have. If you notice, we do have tendency to be very close to the upper limits instead of the middle. So we're not at 0.7. Most of the time we're over 0.8. That means two things. Either the process is really going out of control, or that the configuration for the control limits is incorrect. And maybe the reading should be adjusted to like 0.7 and 1, right? So that depends on what your process is and what you understand as the process. So the goal here is really to understand that whatever your domain is when it comes to the data that you're doing, whether it's sales, predictive analysis, or whatever, it will know if you provide the system prompt properly, it will know to interpret this chart just like it did, right? It's telling us that some of these data points are out of control and it's trending out, it's trending over the limit. So it will understand that clearly. But so this is how we do it with code, right? And this can get very intensive, a lot of code, a lot of stuff. But how do we do it with no code, right? So there are platforms out there that are very powerful to do that. And in those platforms, basically, what you do is you sort of build something similar to this. In this case, this platform is N8N, right? I'm not advocating for it, but this is a good example of how with metadata we can build agents, right? Because if we build our metadata properly, the MCP protocol enables us to orchestrate and build agents. So the idea here is, if you remember the code that we just looked at, we have an input message. We have a large language model, which is Gemini in this case. We have a memory, simple memory in this case, which is just in memory. It's not storage like a database or something like that, but depending on your process, you can use that. And we have the orchestration engine, which is this agent block. And how do we define what this agent should do and how it should work? Is because we told it to based on our prompt. If you remember, we actually said to it, okay, build the system message, right? And the system message basically does what we're talking about, right? We're saying, hey, you are, let me just blow this up a little. We are actually saying, hey, you are an agent that will do the following things, right? And we build the system message here, just like we did, right? So we can do that. And we also can give it a system prompt, right? So a user prompt. And the user prompt really we're saying is, hey, read the new telemetry data that comes from the input. And what that does basically is we're sending the user prompt in a way of a data entry into the chat engine, right? So this is how we actually go ahead, we build the system prompt and the user prompt, and we orchestrate this agent workflow. So basically at this point, what the agent just basically does is that, let's say if we simulate the information, we just basically can go ahead and grab this payload here, right? Type it in, and this simulates your devices, right? This is your device simulating data feed. And you send the data, and what it will do, it will just go ahead and spin off the information from the agent, right? Execute the nodes, executes the analysis node, and it knows, hey, I saw this data, right? I received this information, reading of 0.89. The process is concerning because the latest value is very close to UCL, and so on. So it's basically telling us, hey, well, you're trending in the out of control conditions. And I could continue to put in more values come in, and it will analyze this window and tell me what is going on, what is trending. How is it trending? Is it going out of control, or is it coming back into within control limits? So if you look at this really quick, right, and you're saying, okay, so that looks nice, easy, drag and drop. How do they build these agents? What is the magic behind this? If you look at the metadata to build this, and I'll show you really quick, you will see that basically these agents are being built using line chain components, right? So they're basically using the same framework to orchestrate that no-code platform, but they're passing all these components. So you can build, if you wanted to spend the time to build a UI on top of your platform, you can do that, but you can use a framework like LangChain or LangGraph and build your AI agents. And many other frameworks, right? Microsoft has a different one. Google has a different one. There are many frameworks out there that enable you to do basically the same thing. All right, so I think we reach our time is 12:45. We have a couple of minutes for question. Any questions out there? While you can type them on the chat, but please reach out to the GitHub repo, monitor our progress, our projects that we're deploying. Also, please keep up with us on the community. We'll continue to build and add more presentations. We're queuing up presentations for data engineering. If you're interested in data engineering, I'm going to be covering topics, about 5 or 6 sessions around this book, and also a GitHub repo. So this book has a GitHub repo as well that enables you to build from concept to production a data pipeline with not just the processing of data pipeline, building a data lake, data warehouse, but also creating visualizations. And you can take a look at the QR code, scan it, it will take you to all the GitHub projects for data engineering as well. But anyways, if you don't have any questions, I do thank you for joining us today, and I wish you a good day. Thanks, everyone, and I'm looking forward to the next opportunity to speak with you. Thank you, everyone.